How's it going, everybody? A question came to me via the methods of social media, and I won't say which method, but it was through social media. Actually, my wife received it from somebody else, through somebody else, and it was actually addressed to me. So I decided to take a couple minutes and actually answer the question, and it's one of those questions that is often and I guess the best way to refer to it is often misunderstood. So the question was, what is the difference between directed broadcast and subnet broadcast? And there's a common misconception about what the differences between the two are. Now, typically the way that this works is if you have a router, let me go to grab this. You have R1, right? And you have a LAN segment here, you have a LAN segment here, and you have a LAN segment here. What I mean by LAN is a local area network, so any private IP addressing scheme you might have in place. Doesn't matter what the IP addressing scheme is, this is going to be RFC 1918 space. Now let's say you also have a WAN connection. So this guy goes out here to another router. Okay, and the idea here is that let's say this is a /30 subnet. So this is maybe a PPP link between you and your upstream provider. So this is .2, this is .1, and obviously you know that if it's a /30, it's going to be a .252 in the last octet. So what this means for you and I, let's say this is a /24 subnet, this is a /22, this is a /20. Now, typically what happens when you're dealing with subnetting, and this is actually how this breaks down. If you don't understand what subnetting is or how it works, then it's going to be much more difficult for you to understand this. So the general idea here is if you have an all 255s broadcast, right? All 255s mean that you are going to send a broadcast packet out every interface on a router. So if you type in ping 255, 255, 255, 255, what you're actually doing is you're pinging out every interface on that device. Right? So you ping out on every interface on the device. Now, here's the kicker. What that means to you and I is when you ping out every interface, any devices that are on that network that can respond to the ping will respond to the ping. So the one thing that I commonly see in like network discovery and things like that, because when you're working inside and trying to discover a new network that you may not be familiar with, I tend to do that just to see typically your network devices like your routers, switches, access points, firewalls. Those devices will respond to pings. End devices typically will not. So a Windows laptop, a Linux laptop, a Windows desktop, Windows servers, they typically do not respond to a broadcast ping, right? So the idea here when you're dealing with all of this, when you're dealing with this guy right here, you are sending traffic out every interface and you are going to receive back in a response. So you're going to send out an echo, right? A ICMP code 0 type 0, and this is going to be an echo. An echo is you sending, hey, is anybody on this link? You're also going to receive a echo reply. So this is code 0 type 8, I believe is what the 0 and 8, I believe is what the it comes back in as. This is an echo reply. And depending on where you are in the network, what devices you are on, who's sending it, will depend on the type of transport, whether it's UDP, ping, ICMP, or some other type of transport that's out there. Depends on the device. I'm not going to go into the details on that. But so you'll get an echo reply when you send this out. That echo reply will be from any devices on this LAN, and this LAN, and this connection here that can respond. So if something isn't showing up, so if you're not, let's say you have 200 IP addresses in your DHCP scope that are allocated when you check your DHCP bindings, but you only receive an IP address back in maybe 2 or 3 responses. Don't worry about that. That is common. So don't think that everything is broken. Now, that's typically how this stuff works. The one thing that I want you to be very cognizant of is when you're doing this, this is all hosts. Now, this is not all multicast hosts. So there's the difference between the 224.0.0.1 and 2. So that's link local host, right? This is the all broadcast IP. So when you don't know about something, This is the layer 3 all hosts broadcast. If you are looking at if you're looking at a packet capture, you would see all F's in the MAC address. So it'd show up as literally all F's. So I'm just going to shortcut this to make it easier to write out. And it would actually show up like this in the layer 2 header, because you're saying it's an all host broadcast. So the MAC address destination field in the MAC address would be all F's, which for layer 2 this is broadcast, for layer 3 this is broadcast. Everybody. Now this is all hosts, right? This is going out every interface. When you have subnet specific broadcast, this is when I go out and I do a 10.255, which happens to be my home network /24. This is my home network IP range, right? So what I do is I go out and if I ping the broadcast address. So let me clarify some stuff real quick for you. When I'm pinging the all hosts or the local subnet broadcast, that is 10.255.1.255. The subnet 0 is 10.255.1.0. So what that means to you and me from a /24 perspective is this IP address and this IP address cannot be assigned to any devices on that LAN, right? So this is the local subnet 0. So and then you have the all hosts broadcast for that local subnet. Now you also have the .1 through .254. Are these applicable? Yes, they are, because you can assign these IP addresses, anything inside of from here to any host or devices that might be on that particular subnet. So that's where that comes into play. So when you ping to this IP address right here, the 10.255.1.255, you are effectively pinging out to every device on that local subnet. Now, whatever devices respond, typically, at least in my network here at home, I have a Cisco switch and a Cisco access point. Only those two devices will respond. And that's how it's typically supposed to go. Now, other people will have mentioned that the directed broadcast. Directed broadcast typically is when you're trying to do off subnet type stuff, to where you're trying to go from, like, you have another subnet over here and you're trying to do directed IP broadcast and you try to get over to here and you try to ping. So you ping this IP address right here, which we'll say this is 1.1.1.1. So from R1 you ping 1.1.1.1 or 1.1.2.55, and you get all the response. Any devices that are on this subnet over here respond to this guy's ping. So typically I don't recommend you enable that. It's typically a security flaw if you do. I don't see a valid reason to use it, unless you're doing some sort of reconnaissance attack or you're trying to do network discovery. But quite honestly, I see no value in it personally or professionally, so I never use it. So, but that pretty much boils down what's going on here. So just to recap what we've already covered. If you want to ping out every interface on a router that's got an IP address that is, and each interface is in the up network type, what that means to you and I is that there is a port plugged into the router and the link status, so layer 2. So layer 1 here is up and layer 2. This typically means encapsulation right here, which means that the layer 2 encapsulation on this side here and this side here is an agreement, okay? And up just means it's physically plugged into the router, in case you didn't know what that meant. So that's pretty much where it's at. I hope that this has been informative for you, and I'd like to thank you for viewing.